This week, Lab TV travels to an Air Force Research lab in Dayton, Ohio, to meet an engineer who makes very tiny pearls. These are not like your mother's pearls. You can't wear them, and you can't even see them. They're called NanoPearls.
I work with nanomaterials. In particular, I work with a material called carbon nanopearls. You can't see it with the naked eye. They're made up of flakes, think of like snowflakes, but tiny flakes of carbon. So these tiny flakes of carbon make this spherical carbon nanopearl. The nanopearl word comes from the carbon nanomaterials being linked together like a pearl necklace. Kind of like seen on here, they're all linked together.
Each of the pearls on this necklace is about 100 nanometers across. And each nanometer is 1/1,000,000th of a meter. So these are really small pearls.
Very, very, very small. You can't see it with the naked eye. Think of one strand of hair, human hair, and it's actually smaller than that. So you can't see that with the naked eye. You have to use a special microscope that uses electrons to look at the image.
So what's so special about nanopearls? Well, for one thing, they're made of pure carbon, and carbon is an amazing element. If carbon atoms are arranged in a rigid network, you get diamonds. But that stuff in your pencil is also carbon. It's called graphite. Those carbon atoms form in layers. So when you write, the graphite layers slide off onto your paper. Lately, scientists have been using carbon to make nanomaterials, like nanotubes and now these little nanopearls. Let's see how nanopearls are made.
You have a tube, a glass tube, and you have nitrogen flowing through the tube. As the temperature is heating up, you want to open the other tank, which has acetylene, to flow through this tube. The acetylene is the carbon source. That's the source you want to use to help grow those carbon nanopearls. So once you hit about 845, you have the acetylene flowing through. And at 850, then that's when the temperature is going to stay there for a good 2 to 3 minutes. And that's when you have a nickel catalyst. A nickel catalyst is something that's there to help the carbon nanopearls grow as well. As the nickel is coming off, you have carbon from the gas that's flowing in, going into that void. So you have nickel coming off and you have carbon coming on, and it's forming that nanopearl.
Like nanotubes, nanopearls are great conductors of electricity. And that has scientists pretty excited.
They're being looked at for flat panel TVs because they can emit electrons, so they could replace the plasma and the LCD TVs that are currently on the market.
The new TVs could use carbon nanopearls to transmit electronic images. It's called field emission display, or FED. Those flat TVs would have great picture quality in a huge durable screen, less than ½ an inch thick.
Everything about materials engineering is exciting to me. You're not just limited to doing one thing. When I started off, I started working with semiconductors, and now I work with nanomaterials. I started with carbon nanotubes, and now I'm working with carbon nanopearls.
And now that she can grow these nanopearls, she's looking for all sorts of uses for them. And who knows, 10 years from now we could all have energy-efficient, long-lasting TVs made from her nanopearls.
I could say, hey, I helped work with that. That's carbon nanopearls. I helped do that. Those TV panels are due to some of the work that I did.
To find out more about nanotechnology, carbon molecules, and carbon nanopearls, check out labtvonline.org.